Okay, so let's talk about polynomial operations for a little bit. This is a pretty simple skill set, but once you really get a handle on it and feel solid about it, it'll really help out because it pops out in different forms on the SAT math section, so it's definitely worth having a grip on. Before we get to the operations themselves, let's talk about notation just for a second. So here you have f of x. What does that actually mean, right? So this just means that you have some function that we called f. Okay, we just named some function f, and we're saying that the f is written in terms of x. F is a function of x. F depends on x in this way. So then what does g of x mean? Well, g of x just means we just have some other function. It's different because we have a different letter for it. Some other function that also depends on x, and that dependency is described in this way. Okay? So if we're then given f of x equals this, g of x equals this, how do we know what f of x plus g of x is? So at first it might be like a little bit daunting with the notation and all the polynomials and stuff, but it's very simple. So f of x plus g of x, no problem. Just write that down. Write down f of x, okay, that's going to be 4x to the power of 3 plus x minus 7, okay, plus g of x, plus x to the 3 minus x squared plus 6x plus 1. There you go. So usually when I actually write these down, I like to write parentheses at first, just so in my mind the two are grouped apart, so like I know that here this group is f of x and here this group is g of x. But in the case of addition, you don't actually need parentheses, so I'm going to remove them again to avoid confusion. But so once you've written this down, you have you have an expression for it, right? So what can we do now? Well, something I'm sure you're very familiar with, just combine like terms. So we have a 4x cubed. Do we have any other x cubed terms? Yes, we do. Okay, so let's just combine those. 4x cubed plus x cubed, 5x cubed. 5x cubed. All right, so we took care of this term, we took care of this term. Let me actually even cross them out so we keep track of what we have used and haven't. Okay, do we have any x squared terms? Yes, we have a negative x squared, and that's the only one. No problem. So then just write that down. It's the only one we have. Let's cross that out. Do we have any just x terms? Yes, we do. We have plus x and we have plus 6x. Combine them makes plus 7x, right? So plus 7x. Let's cross that out. And finally, we have our constants, right? So negative 7, and then you have a plus 1, so that just makes negative 6. And that's it. That's all there is to it. You just took one function, took the other function, added them together. Now, if you had subtraction, it's just something important to note that, for example, if you had, let me just move up here. So if you had, let's say, this function, f of x, minus x plus 1, okay? So here the important thing to note is just that, you notice here I just removed the parentheses and just did the operations. That's because it was addition. You can just do that easily. Be careful when it's subtraction, because if you have to, for example, if you had like subtract these two, don't forget to distribute that negative, right? So it's because you're subtracting x and you're subtracting 1. So if you rewrote this without parentheses, it would be minus x minus 1. You see what I'm saying? And conversely, if you just started with this, if you had this function, f of x minus x minus 1, still got to distribute the negative. It would be minus x and then minus negative 1, so plus 1. So that's just something to watch out for. I think it's a pretty common mistake. So from here, let's move to another example that's very much related to polynomials, but again, it really relies heavily on your knowledge or understanding of the notation.